This is lesson 2-5A from the Algebra Readiness textbook. For today's lesson, you will need your notes packet and a sharpened pencil. Pause the video to gather your supplies and work the study guide problems. When you're finished, click Continue. The first study guide problem is to state whether the equation is true, false, or an open sentence. I have to remember what a true, false, and open sentence are. We learned in our previous lesson that a true sentence was one that when you solve the left side of the equation and solve the right side of the equation, that the answers are the same, or you get a true statement. A false equation is one where the left side is not the same number or value as the right side. And an open sentence is an equation that contains a variable and you can't solve it down to one number. So in this equation, 2 times 2c plus 5 equals 5 times negative 2 plus 9, I see that there is a variable. And because there is a variable, I know that this is an open sentence. And how do I know that? Because there is the variable c. The next problem. State whether the equation is true, false, or an open sentence. I notice right away that it is not an open sentence because I don't see a variable. That means I need to solve this and determine if it's true or false. When I am solving this problem, I need to solve the left side of the equal sign and the right side of the equal sign using the order of operations. Negative 5 times 5 plus 9, negative 5 times 9 plus 5 is 14. 14 times 5, well, 10 times 5 is 50. 4 times 5 is 20, so 70, negative 70. And so on the other side, I've got negative 2 plus 5 is positive 3, and so that equals positive 21. And so what I end up with is a false statement. This is not true. And how do I know that? I can just reference the work as my explanation, showing that negative 70 is not equal to positive 21. The next problem, write an equation for the word problem below, and is the given value a solution? Prove it. A farmer sees 56 of his cows out of the barn. He knows that he has 83 cows altogether. Let C represent the number of cows in the barn. Are there 33 cows still in the barn? So we're going to save this as kind of part B. So save this for later. And let's also write down, let C represent the cows in the barn. C equals cows in barn. So now I'm done with this too. Now I only have to work with the first two sentences. Let's read that again so we develop a firm understanding. A farmer sees 56 of his cows are outside of the barn. He knows that he has 83 cows altogether. So how could I write an expression to represent the total number of cows? Well, it would make sense that cows in the barn plus cows out of the barn equals my total number of cows. So in solving that, now I want to replace these words with numbers or variables. He has 56 cows out of the barn. So 56. He has 83 cows altogether. That's total cows. And C cows in the barn. So I can use the expression C plus 56 equals 83. Now I'm going to go to the part that we saved for later. Are there 33 cows still in the barn? That means that my C value is 33. Can my C value equal 33? So we're going to check that by putting 33 in for C. 33 plus 56 equals 83. I'm finding out if 33 is a solution. So is this and if it's a solution, that makes the equation true. 33 plus 56 is 89. Does 89 equal 83? No. So are there 33 cows in the barn? No. In fact, you could go a step further and figure out how many cows are in the barn by subtracting 83 minus 33 and getting 50. 50 cows are in the barn. And I'm running out of space. So that's how you do that first problem. Today, our lesson target is to solve one-step equations using subtraction. And so this time, instead of me giving you a number, asking if it's true, I'm asking you to figure out what would make it true. So you need to find the solution. Solving an equation is like keeping a barbell balanced. If you add weight to or subtract weight from one side of the barbell, you must do the same to both sides, or you would have it all lopsided. So, for example, you can see here that I have 2 barbells here. And so if I remove one barbell from this side, I would also need to remove a barbell from the other side to keep it balanced. Otherwise, it would not be easy to maintain the weight. It would be unevenly distributed. The same thing is true when we're solving equations. We are going to use inverse operations to both sides of the equal sign. Write down the definition of inverse operations in your notes. An inverse operation is when you undo the operation to get a variable alone. Think of an opposite operation. To make this point, make sure you know what the inverse of each operation is. So the inverse operation of adding is subtracting. The inverse operation of subtracting a number is to add a number. The inverse operation of multiplying is dividing. And the inverse of dividing a number is multiplying by that number. Make sure that you have these all in your notes. Pause the video if you need more time to write. The first problem we're going to do as an example is to solve x plus 6 equals 4. Now remember, I want to get x. I want to know what the value of x is. So I'm going to undo what's happening to x, but whatever I do to one side of the equal sign, I have to do to the other. To help me visually recall one side of the equation and the other, I draw a line that extends from my equal sign straight down. It makes a wall. That wall shows me where the two sides of the equal sign are. Now I see that x is adding 6, so I'm going to subtract 6. But when I do whatever I do to one side, I must do to the other, just like when I'm taking weight off of a dumbbell. Whatever I do to one side, I have to do to the other in order to maintain an equivalent amount. Now, please make sure to show that something equals 0. 6 minus 6 equals 0. Put an X through the entire amount. We are not going to write a 0 down here. That ends up getting messy. And now what's remaining is the X. And the 0, by just Xing it out up here, shows that that's all gone. What's remaining is this X, so I bring that down. Your equal sign always goes on the line that you drew to divide, and then you solve the problem on the right. 4 minus 6. Well, if I have 4 plus a negative 6, or 4 minus 6, I end up with negative 2. Now we're working on two things. First, we're working on how to get x by itself, but we're also working on having a consistent method for showing our work in a problem. So make sure that you show your work like I'm showing my work. I also want to show you that you can check your answer. You can check your work by substituting -2 back into the original problem. So is -2 my solution? So -2 plus 6 equals 4. Notice I went back and I put -2 into this original equation. But wherever x was, in this case, I put -2. And now I'm seeing if it makes a true equation, just like we did yesterday. Is -2 plus 6 equal to 4? If you're somebody who still struggles with adding and subtracting negatives, remember that's 2 negative tiles plus 6 positive tiles. These equal zeros, and what's remaining is a positive 4 tiles. 4 does equal 4. So yes, this is a true sentence, so that means that I do have the correct answer. All right, we're going to try these 3 together just to get the hang of how these look. Make sure you're doing these 3 with me. When you solve any equation, you have to identify what your goal is. And for A, my goal is to find out the value of x. You do not have to put a box around it if you do not like to, but I like to. It helps me figure out what my goal is. Now, I work with the side that has the x, and so in this case, it's the left-hand side. It won't always be the left side. It's the side with your variable. Now, I see that x is adding 8. The inverse operation of adding 8 is to subtract 8. So notice how I write -8. Then I go to the other side and I immediately write -8. Then I draw a line to show equals. Now I'm going to tell what each side equals. Add 8 minus 8 equals 0. Again, I'm not going to write 0. I'm just going to cross it out because it's all gone. The only thing that's remaining is my x, so I bring that down. An equal sign always goes on my dividing line, and then I write the value of the right-hand side. 3 minus 8 is -5. X is by itself or isolated. There's nothing else on the left-hand side, so I know I'm done. Then I go ahead and I check my work by substituting -5 in for x in the original problem. -5 plus 8, does that equal 3? If this is a true sentence, like yesterday, then I know I did the problem correctly. 3 does equal 3, and so I know that -5 is the correct answer. Okay, going on. Letter B. I'm trying to find out what the value of D is. I draw a line down my equal sign. That's where my equal sign goes. This time I'm working on the right-hand side of the equation, and it says D plus 1. The inverse of adding 1 is to subtract 1 from both sides. So I write -1 on both sides of my line. Then I draw a long line to indicate equals. Then I tell what's remaining on both sides of the equal sign. 5 minus 1 is 4. The equal sign is always on the line. I have D, and then 1 minus 1 is 0, so that just goes away. Now D is by itself. I have D equals 4. Before I can say definitively that that is the answer, I check my work by substituting 4 back in for my variable in the original problem. 5 equals 4 plus 1. 4 plus 1 is 5. 5 equals 5. Yes, That's true. I have now checked my work, and I'm positive that 4 is the solution that makes that equation true. Okay, one more problem. My goal is to find out the value of C. Then I ask myself, what's happening to C? It's adding -4. And so I need to do the opposite. And the opposite is to subtract -4. Subtracting a negative or adding 4 means the same thing. Whatever the sign is before the number, in this case it's negative or minus, you are going to add. So I'm going to add 4 to the other side. And so this equals -4 plus 4. Those are opposites. That equals 0. I am left with C on the left-hand side. On the right-hand side, I have -5 plus 4, which equals -1. Before I can say for certain that I have the right answer, I need to check my work. In order to check my work, I see if -1 is a solution by substituting -1 in for C in the original problem. -1 plus -4, does that equal -5? -1 plus -4 is -5 equals -5. That is true. -4 makes my equation true, so I know my -1 is that solution to the equation. All right, now it's time for you to try some on your own. I want you to try these 4 problems, making sure you check each answer. Then come back, after pausing the video, come back and see if you get the same answer. Hopefully you've paused the video and you've tried each problem and checked it so you know your answers are right, and you're just checking to see or to verify that you got the same answer. The first one, I see that X is right here, and I look at the number before 54. I'm not actually looking at this plus sign. I'm looking at the fact that 54 is a positive number. This is really positive 54. So I am going to subtract 54 from both sides. Then I draw a long line to show equals. This is 0, and I'm left with a positive X, or just X. X equals 44. To verify that that answer is right, I need to check my work. 54 plus 44, does that equal 98? Well, actually do the math. Don't just write 98 equals 98. I see when I actually do the math that 98 equals 98 and that that is the correct answer. So 44 is correct. Next problem. I'm trying to find out the value of H. H is adding 35. So I'm going to subtract 35 from both sides of the equal sign. H is remaining on the left-hand side. 35 minus 35 is 0. My equal to sign always goes on my dividing line. 15 minus 35 is a -20. Before I can say definitively that H equals -20 is the solution, I'm going to check my work. -20 plus 35, does that equal 15? Well, yeah, I learned that when in chapter 1, when I am adding two numbers, one of which is negative, I subtract. 35 minus 20 is 15. The number with the biggest absolute value is 35, which is positive. So I know my answer is positive 15 on the left and positive 15 on the right. So my answer is indeed -20, does make that equation true. All right, the next problem. I look at 89. This is a positive 89 because it doesn't have a positive or negative sign. I am not actually using this plus sign to decide to subtract 89 from both sides. So I subtract 89 from both sides. 89 minus 89 is 0. What's remaining is y equals 112 minus 89 is 23. Before I can say for certain that 23 is the solution, I need to check my answer by substituting it back in for y. 89 plus 23, does that equal 112? When you do a side problem, you find out that this does equal 112. The next problem. T plus negative 2 equals negative 66. So I am going to add 2 to both sides. This equals 0. T equals negative 66 plus 2 is a negative 64. The signs are different, so I subtract the two numbers and make it negative because the 66 has the bigger absolute value and is negative. Again, before I can say for certain that negative 64 is the right answer or the solution, I need to check it. T plus, nope, I'm sorry, not T. I need to put negative 64 in for T. Negative 64 plus negative 2, does that equal negative 66? And it sure does. Negative 66 equals negative 66. Make sure you're actually checking each answer for its accuracy. Now I'd like you to pause the video. I want you to do the remaining problems in your notes packet. These 4 and these, and these 2. Come on back and check how you did it with how I did it. All right, you're ready to do to check your work. Hopefully this is starting to make some sense for you. X is adding 47, so notice I write minus 47 below the left and the right side. But the side with the variable is the side I'm working with. So X is adding 47, so I subtracted 47. This equals 0. Now I go to the other side without the variable. Negative 45 minus 47 actually ends up being adding the 2, and I get negative 92. Then you should check your work to check so you are certain that negative 92 is the solution. So negative 45, does that equal negative 92 plus 47? Well, this is negative 45, negative 92 plus 47. I subtract the two numbers and I get 45, and then it's a negative answer because 92 is the bigger value, absolute value, and so yes, this is right. Right, next problem. P plus 146. I work with the side that has the variable. It's adding 146. The inverse of adding is subtracting 146. This equals 0. P is all that's left on the left-hand side. My equal to sign goes on that dividing line where the equal where my equals go. 71 minus 146. You're going to have to do a side problem. I always get kids who ask, well, can I take and do a side problem where I put 146 on the top? Yes, you sure can. 6 minus 1 is 5. And 14 minus 7 is 7. My answer is 75, and my answer should be negative because I subtracted. And so I get negative 75. Then when you check your work, hopefully you guys have done this so that this isn't going too fast. You were supposed to pause the video so that I can, when I'm explaining this quickly, that you're not seeing it the first time. So negative 75 plus 46. See how those are different signs? So I subtract and give the sign of the bigger absolute value. So 146 minus 75 is 71, and it's positive 71. Now I'm sure that I have the right solution because it made it true. Next one. Here I've got negative 88 plus z. Some kids go, oh, I don't know if I'm supposed to add or subtract 88. Remember, this is not the sign that's telling us what to do. It's the sign before the number. That is a negative 88. So you are going to add 88 to both sides of the equal sign. I'm left with z equals 88, because 0 plus 88 is 88. Then when I check it, negative 88 plus 88, does that equal 0? And yes, it sure does. And so I'm certain that this is the right answer. Okay, then the next one on this page. Draw a line down your equal sign to differentiate the left side from the right. I work with the side that has the variable, h plus negative 219. This is the sign that tells me that I need to do the inverse of. So instead of it being minus or negative 219, my job is to add 219 to both sides. So negative 176 plus 219. You should have done a side problem. And in your side problem, you'll probably want to put 219 on the top and subtract 176. And you should get I get 43. Now, negative 176 is negative, 219 is positive. 219 has the larger absolute value, so my answer is positive 43. Now, before I can say for sure that that is the solution, I need to check my work by substituting it in for the variable. So negative 176 equals 43 plus negative 219. And when I add that, I really subtract the two numbers, 219 minus 43, and I get 176, and it should be negative 176. And so it is the answer, or it is the solution. The next one, last two, I start on the side with the variable. It's adding 9, so I subtract 9 from both sides. I draw a line to show what I'm writing what it equals after I do this, and I'm left with k, negative 19 minus 9. That's 19 negative tiles, plus 9 more negative tiles. I am further negative, so I need to add and keep the sign. This is negative 28. Before I say for sure that that's the answer, I need to check my work. Negative 19 equals negative 28 plus 9. Negative 19 equals, so these two signs are different, 28, so I subtract, and I get negative 19. So yes, this is true, and so I know for sure that was the right answer. Now make sure you're checking this one. What do we do here? C minus negative 12. Please convert your subtraction problems to adding the opposite, C plus 12. Some of you like to just connect these and make a super plus sign. That's okay. Others of you like to rewrite it as adding the opposite. That is also okay. Then, now I'm ready to isolate my variable. I'm adding 12, so let's subtract 12 from both sides. Then over here, this equals 0. C is remaining on the right-hand side. 19 minus 12 is 7. So C equals 7. Before I can say for sure that that's the answer, I always check my work, as will you on your homework. 19 equals 7 plus 12. 12 plus 7 does equal 19. And so I'm positive that my answer is right. Okay, your homework for tonight is this assignment. It is also written in the Google Classroom post. So give this a try and seek extra